All right, let's just jump right in. Look, we're all feeling it, right? This absolutely breakneck speed of AI progress. I mean, stuff that was pure science fiction just a couple years back is now like running on our laptops. But there's something else going on. Something behind the curtain that's starting to spook even the people who are building this stuff. Now, this isn't some random person on the internet. This is Jack Clark, a co-founder of Anthropic. We're talking one of the biggest AI labs on the planet. So when a guy like that calls his own creation a mysterious creature that he's deeply afraid of, you gotta pause. You just have to ask, what on earth is going on? And that's really the core question we're gonna tackle here. What is happening under the hood? What are these developers seeing that has them so worried? Well, the answer, it all comes down to one core idea. An idea that is, no exaggeration, quietly rewriting our future as we speak.
Think of it like an engine that's powering this incredible, almost runaway growth. It's a feedback loop. And honestly, once you get your head around this loop, you'll see exactly why the world of AI is simultaneously filled with so much excitement and so much dread.
So the fancy term for it is recursive self-improvement. But let's just boil that down. All it really means is AI making better AI. That's it. It's when the AI itself stops being just the product of research and starts becoming a part of the research team, creating a cycle where each new version is smarter, faster, and better at designing the next version. And this idea completely changes the game. I mean, think about it. For all of human history, progress has been limited by us, by our slow, mushy, carbon-based brains. It's a slow grind. But AI, it works at the speed of silicon. It's just relentless. It can run millions of tests in the time it takes a human team to, find a time that works for everyone on the calendar. The scale is just different. Okay, so I know this might sound a little bit like sci-fi, but here's the thing. It's not. This isn't some far-off prediction. It is happening today, right now. So let's actually look at how this engine is already fired up and running in the real world. First off, let's get one thing straight. Forget the Hollywood movie version, where a single AI locks the doors, rewrites its own code, and suddenly becomes sentient. That's not what's happening. The reality is, well, it's quieter, but honestly, it's way more powerful. It's not one big AI, it's a whole system, a whole pipeline of specialized AI tools that are automating every little step of the research process. That's where the real acceleration is coming from. Let's take a look at a real-world case study. Google DeepMind has this thing called Alpha Evolve. And no, this isn't like a chatbot you talk to. It's a super specialized tool built for one job and one job only, discovering and improving algorithms. And how it works is honestly kind of beautiful in its simplicity. It starts with algorithms that already exist. Then it mutates them, mixes them together, tweaks a variable here or there to create thousands of new baby algorithms. Then it tests all of them at once. The ones that work best, they're the winners. They get to go on to the next round and create the next generation. It's literally evolution on fast forward, running at the speed of a computer. And the results? They are absolutely mind-blowing. We're talking about Alpha Evolve cracking a math problem that the best human minds were stuck on for half a century, 50 years. It's also optimizing Google's massive data centers, saving insane amounts of energy. And here's the kicker, the perfect loop. It's now helping design the next generation of computer chips, TPUs, which are the very chips that future AIs will run on. You see it? The AI is designing the hardware that will make the next AI even smarter. Okay, for our next example, let's look at a company called Sakana AI. They're taking this whole idea one step further. Their system, it has a cool name, the Darwin-Gödel machine, doesn't just find new algorithms. It can actually look at its own programming code and figure out how to make it better. It treats its own source code like a puzzle that it needs to solve. And check out the impact. On a standard test for software, it started out with about 20% accuracy. Not bad. But then they let it loose to optimize itself. The result? Its performance jumped to 50%. It more than doubled its own effectiveness. And remember, this wasn't a team of programmers pulling an all-nighter. The system did this by itself. Okay, so we've established this is real, it's happening, and it works. But what does it all mean? What are the consequences of this new machine speed pace? Well, this is where we circle right back to that fear we talked about at the very beginning. It all starts with this number, 1 million. That's roughly how much faster a signal travels through a computer chip than a signal travels through the neurons in your brain. 1,000,000 times faster. This massive speed difference, it's the root of everything we're about to talk about. And that speed advantage isn't just a number. It translates directly into time. Think about a huge research project, the kind that would take a team of brilliant PhDs 3, 4, maybe 5 years to complete. A recursive AI system can now burn through that same amount of work in just a few days. It's like we're compressing the timeline of discovery itself. So, when everything gets compressed like that, it creates a few, well, massive problems. First, you've got the speed problem. It's just moving too fast for any human to possibly keep track of. Then that leads to the comprehension problem. The AI starts creating solutions that, yeah, they work, but they're so weird and complex that we have no idea how they work. And if you can't keep up and you can't understand, well, then you have the control problem, right? How do you possibly manage a system that you can't follow and you don't fully comprehend? And there it is. We're full circle. This very technical, very real process of recursive self-improvement leads right back to that very human emotion we started with, fear. So here's the big unanswered question. It's the one that basically defines the entire field of AI safety. If a system is getting smarter at a speed we can't match and in ways we can't understand, how do we stay in charge? How do we maintain any kind of meaningful control? Because all our old ideas about safety and oversight, they don't work in that world. And this leads to what some researchers think is the best case scenario, which is pretty chilling. They call it the pet owner analogy. Imagine a future super smart AI is completely friendly to us. Even so, the relationship might be like ours with a pet dog. We love our dogs, right? We feed them, we protect them, but we don't ask for their input on big life decisions. We are in complete control. That's the worry. A future where humanity is safe and cared for, but we're no longer in charge of our own story. Which brings us to this final thought. It's a quote that just perfectly captures where we are right now. The feeling is that everyone, the people building this, us using it, maybe even the AI itself, we're all just kind of sitting in the dark together, looking at this strange shape in the corner of the room. And for a long time, we told ourselves, oh, it's fine, it's just a pile of clothes on a chair. But now, that pile of clothes is starting to move. And no one, not even its creators, really knows what it's going to be when it finally stands up.